Okay, so next example about the partial derivatives is, okay, I want to give another example which is not in the notes, where the instruction is, given that z is a function of x and y, okay, we have two variable function, find the partial derivative z respect to x if the equation is given. Okay, so the last few examples that I gave you, the form is in this form, already in this form, which is, for example, last time I give you z is, yeah, I can just look at here, z, just two variable function. Okay, for example, this one, x cubed y4. So x cubed y4, it is already in the form of z is the function of xy. Okay, where z is the output function, xy is the input variable, z is the input variable, output variable, xy input variable. But in this case, for this particular form, you can see the mix. Okay, the z and y, they are mixed each other. So you have to, the thing that you can do is, we are trying to reform, rearrange so that it's become in this form. But do you think that one is easy to be done? That is because of, maybe it is can be done, but then it is quite complicated, right? Because you have yz here and then non-z, then it is impossible. I don't want to say impossible. Maybe there is a way, but it looks like it's become messy. Okay, what I mean messy is the expression is more complicated. So why not we just leave like that? Leave like in this form. Okay, but then in order for you to find the derivatives z respect to x, you cannot just directly differentiate as usual. Okay, but the thing that you can do is you have to differentiate implicitly. So I mean, before you learn about the variable function, maybe you have just a single variable function. Okay, this one, and you can separate y and x, just x, y on the left, x on the right, isn't it? But let's say you have sine of xy equal to x squared y plus y squared. So then you want to get the dy dx. You have to differentiate dy y with respect to x. Now we are talking about single variable function. So then the way that you can do, if you want to, if you want to apply the technique, just a common technique, which is you need to separate y, and then the y is on the left and then x is on the right. But do you think this one easy to be done like that, where you can just rearrange y and then just everything in x on the right side? Also impossible, because you have the sine of xy and you at the same time you have this one, and then maybe it can be done, but you have to deal with the arc sine, the inverse trigonometric function, and you want to differentiate. I'm not sure whether you still remember on that or not. So again, the expression becomes messy, more complicated. So just what we can do is, in order for us to differentiate with respect to x, we just leave the expression like that, but you have to differentiate this one implicitly. Have you ever heard the word of implicit derivatives? And you can just go Googling if you don't remember. But here, don't worry, I will teach you how you can deal with that. But I don't want to solve this. I want to focus on the example here. So this is the same. This is implicit form, where implicit means you cannot separate only z on the left and only x and y on the right. So it is become, it is quite complicated to be done. Okay, so we just leave the form like that. Now we deal with the implicit derivatives. We differentiate this implicitly. Okay, so now we are talking about partial derivatives. Z respect to x, so y is constant. Okay, so what you can do is, we have to differentiate term by term, which means that you got how many terms there? one, which is yz, and then the second ln z, and then x, and then y. You got 4, 1, 2, 3, 4 terms. So the first term, you want to differentiate whatever expression that you have with respect to x, right? So del x of the expression minus, also similarly for the second term, del x of the ln z equal to del x of x plus del x of y. Okay, now we look one by one. The first one. Okay, now because you want to differentiate with respect to x, so y is a constant, but not z. Z is still a function. Okay, z in this case not variable. Z is a function. It is a variable, but it is a function where it depends on the x and y. So meaning that if you want to differentiate with respect to x, just y only constant, but not z. This is still a function of xy. Okay. So when you differentiate, if you want to differentiate yz, y is constant. So we don't change that. Just look at the z, because z is a function. So y del z del x. Z is a function, but we don't know what is a function. Looks like we just leave like del z over del x. Okay, and then go to the second term, ln z, only z. Remember, z is a function. Okay, so you differentiate. You have to apply the chain rule, because it is just like a simple chain rule. There is a function in a function, then you have to differentiate the outer function, which is ln. So it will give you 1 over z, and then multiplied by the derivatives of the inner function, you have z here. So you differentiate z with respect to x, so you can just put del z over del x, because z is a function. Okay, equal to, now you have only single x, so the answer is 1, plus, and y is constant, so plus 0. Next. Okay, so the next step, after you differentiate everything with respect to x, differentiate all the terms with respect to x, then you have to try to factorize them, because you can see this one, there is del z over the x, which is the thing that we are looking for, right? Del z over the x. So when you factorize del z over del x, so you will have y minus 1 over z equal to 1. Then, because we are looking for del z over del x, so we have to make sure you have to make sure that the only thing left on the left side is del z del x, because you are looking for that. So you have 1 over 1 minus 1 over z. So now we try to simplify. Then it will give you, so you have 1 over yz minus 1 over z. So you can have z over yz minus 1. So that is your answer. Okay, so that is called as differentiate implicitly. Okay, why you always bear in mind z is always a function in terms of x and y. Every time you see z, you will put del z over del x. This is for del x, but if you have del y, then you make sure that x constant, and then every single term need to be differentiated by y. Okay, but this one just for the question is asking for del z del x. Okay, so actually we have a more simpler way. Okay, you still we consider that as we need to differentiate implicitly, but we have another simpler technique. But that one you need to know the formula, but the formula is not so complicated to be memorized, so it's very easy. So this is the thing that I want to show you from this note. Where is it? Second chain rule. Okay, so just look at here. If you have a function of two variable function, the thing that we have done just now. So okay, this is the formula. So I don't want to explain this, but just look at because we have a same function here. You have a function of two variables. So now by using the same function, which is this one. So this is in implicit form. So then you need to make it 0. You have to rearrange the given function and then then rearrange this. It becomes equal to 0. And then how can you do that? How can we make sure that we have equal 0? Yes, you have to bring everything on the right to the left, or you can bring everything on the right, everything on the left to the right. So you can use either way. Okay, so let's say now I try to bring everything on the right to the left. So I have yz minus, so this is another option that I want to introduce from in this video. So yz minus on z, and then you bring x and y to the negative side, to the left side. So you have minus x and then minus y, and this becomes 0. So now you can see this one, right? So now your function becomes you have the equal to 0. Okay, so sorry. So now you give a new name for this new function, which is equal to 0. So instead of you have a small f, so because last time you said that z is the function small f of yz, sorry, xy. Then you give a name which is a capital F, where now your new function is there is x, there is y, and there is z. So you have a new function, you give a new name, which is now you have a 3 variable function, and this equal to 0. Okay, so now x, y, and z, they are in the same level. 3 of them are independent variable. Okay, so this is our assumption. Okay, for you to apply this formula, then you have to assume like that. Okay, so from 2 variable function, now it's transformed into 3 variable function, just for the sake of differentiation. Okay, so now you have to make sure that it is equal to 0. Okay, so now the next step, you are looking for, let's say the question is asking for finding the del z. Okay, let's see, you're going to get the del z based on the question. Del z, there's no del z, del x. Okay, so the formula is you have to every time put minus sign, and then you can see the denominator here is x and the numerator is x, so you have to make it upside down, so negative. But you don't need to put the del, but you need to put the f, the partial derivative f respect to, okay, you have seen this as a denominator, so now it's become the numerator, f of x divided by the partial derivative f respect to z. So now you can see that how can you memorize the formula. It's very easy. If you are looking for z and then over x, so meaning that you have to have x over z. Okay, but don't forget to put the negative. It must contain the negative. If you forgotten to put negative, so the answer wrong. It will not be the same as the answer will not the same as from the previous method, which is this one without using any formula. Okay, now you know capital F is this one in the new version now. Then you have to just look at here. Don't look at the original. Don't look at this form. Don't look at this form anymore. So this is the old one. So now you are focusing on this particular form. Okay, so what is this? So next, as stated here, you have to find the partial derivative for a new f here with respect to x and z. Okay, so now fx. What is fx? Or you can just plug in here. negative. Okay, fx. Differentiate yz respect to x. Now remember, because you have three variable function, so x, y, z, they are all variable. Okay, no function here. Z is no longer a function because you already assume now you have a three variable function where x, y, z, they are on the same level. They are all variable. Okay, so now you differentiate this. Okay, the first one, look at the first term, differentiate that yz respect to x. So now x, right? So yz, they are all constant. So you have 0. That is for fx, so 0. Now look at negative ln z. Z is constant, okay? Z is constant. So Z is constant. So you want to differentiate the constant respect to x. You see, it is 0. Okay? And then the third one, you want to differentiate minus x respect to x, and will give you negative 1. And you want to differentiate minus y, and y is constant respect to x, so it is 0. Okay, and divided by now fz. So now you can see the z, right? So y constant. So differentiate z, you will get 1. So the answer is just y. And then ln z, you want to differentiate to ln z, and z is a variable, not a function. So just negative 1 over z. And in differentiate x, x constant 0. Differentiate y, y constant also 0. And that's it. Okay. Now we are trying to simplify the form. You will get 1 over y minus 1 over z, and we just simplify. So you have z over yz minus 1, which is the same. This one is the same as this. And now you compare which technique is more easier and faster. Okay, for me, I will advise you to use this. As you can see here, if you use this method, and this is not so complicated, how about if you are given a more complicated, more complicated expression? So how can you have to look by one every time you see the z, you have to put the del z over del x. And then if you have to apply the chain rule, then you have to apply the product or the quotient rule and chain rule again, and many layers and so on. So it's easy for you to make a mistake. So that is from my experience when I just look at my students when they don't use this. I mean, they're using this new technique, using the formula that I introduced just now. So I would say 70% for them, I mean, who use that technique, they cannot give me the correct answer at the end, because it will take more steps, and you have to simplify after that, and maybe you can just put the negative, you want to put negative and suddenly you put positive and so on. So easy for you to make a mistake. But for you to use this, is already in there, in the form that you are looking for. But again, still be able to do mistake, because you have to differentiate partially for this one. Again, but then the probability for you to do a mistake is less. This one is less than the previous one. Okay, so then both are correct, but it is up to you. But for me, if you asking for my advice, so my advice is use the new method here. This is more easier. Okay, and actually this one is for I think you need to correct this. So this one is actually for the formula for single variable function. So sorry about that, I didn't realize that. So this one is actually you have to change this, becomes y is the function of x. Okay, so let's say I give you y equal to okay, let's say I give you sine y equal to ln x squared plus y. Okay, so you want to differentiate with respect y, you want to, okay, the end, the question is find out dy over dx. So this one I'm using d because nothing to do with partial, because the variable is just single variable. So find this. So meaning that using the formula, you have to make it equal to 0, right? So you have to make it, this is for this one, okay? then you have to just rearrange. So sin y minus ln of x squared plus equal to 0. So this one, this equation, you have to give a new name, which is capital F. So now your function is becomes two variable. Then you have fxy equal to 0. So this one is actually for y. Please correct that. Y equal to y equal to f of x. Yes, this one. So can you please correct that, so I don't want you confuse yourself. Okay. And then the formula is, you are looking for this one, dy over dx, then put negative fx over fy. As I mentioned before, how can we know the y and the x? So y is as the numerator here and it's become denominator, and here x become this one is denominator, so it's become numerator. So as you can see here. Okay, so this question is for single variable function. So I would say that this is not part of the syllabus because this one is for single variable function. So then okay. Okay, so even though you have d, you have del, so the formula is still the same. You have now, then don't forget to put the negative f, negative, yeah. Okay, so now look at an example. As you can see from the formula here, you want to get del z over del x. So what you can do is, from the formula, negative f of x divided by f of z. And if you're looking for del z over del y, then you have to put negative f of y divided by f of z. So, okay, let's say I give you this example. So, I want to discuss with you this one. Okay, find del z, del x, and del z, del y if z is defined implicitly. Okay, this is implicit function as a function of x, y. So this one, it's defined z is the function of x, y. So you have two variable function, and the equation given is 2x and then y plus z equal to x squared plus y squared minus z squared. Okay, so now you want to find. So the question is, so we want to get del z, del x, and also del z, del y. Okay, so using the formula, you have to make it equal to 0. So here, so you have an option whether you want to expand this or just leave that, just leave this just like that, just leave this form just like that, okay? Or maybe you want to expand. So let's say I want to expand, so I have 2xy plus 2xz minus x squared minus y squared plus z squared equal to 0. And I give a new name for this. So this is, now I have a new function where there is in terms of x, y, and z. Okay. Okay, so now we are looking for del z over del x. So the formula, negative fx over fz. So you differentiate the function here, the function here with respect to x. So y and z are constant. Okay, now you have to think that x, y, z, they are variable, no function here. The function is only capital F. So now differentiate x. So y and z are constant. So just look at the x here. So differentiate x, you will get 1. So you have 2y. Negative. And don't forget to put negative. So 2 to y plus, in this one you have again z constant, so you have 2z, and then now differentiate this one, you have minus 2x, and this one y constant, only y, so this is 0, and this also 0, divided by mz. So differentiate this term respect to z, which is xy constant, so this is 0, and this one z, you want to differentiate with respect to z, so x constant, then you have 2x, and you want to differentiate with respect to z, only x, so this is constant, 0, 0, and then 2z. Okay, so that is the answer. Okay, so now next we go to the del z del y. So the formula is minus fy over fz. So for fz, you can use the previous result. You have 2x plus 2z. Now differentiate f here with respect to y. So x constant, so you have 2x. Okay, differentiate respect to y, xz constant, so this one 0, this one 0, so this one minus 2y, and then this one constant, also 0. So you will get the answer directly. So that is the answer. Okay, but it looks like we can simplify that because they are all, there is 2 there, so you have you can have x minus y minus z over x plus z, and this one you can have no 2, so y minus x over x plus z. Okay, so that is the answer. Okay, so the next one, which is the last one. Okay, this question is I'm taking from the test, maybe test 1, okay, and the question number 2. So you are given the implicit function where z is a function of 2 variables. So in this case, we define the z where z is a function of x1. Okay, so then the function given, you have x squared, you have an implicit function, x squared sine of 2y plus 5z. Okay, for this you don't forget, please don't forget to put the bracket. Okay, if you've forgotten to put the bracket, and then it will end up to be like this, sine 2y plus 5z. So it looks like it is x squared sine 2y and then plus 5z. So then you have to be careful. Okay. So then equal to 1 plus y cos of xz. Also don't forget to put the bracket. Okay, so you need to get the del z del y. Del z del y. That is the thing that we are looking for. So now you have to obtain the f. Okay, your new function where it is contains the x, y, and z. Just a function, okay. So meaning that you have to make it equal to 0. So here I bring everything on the right to the left, or actually you can bring everything on the left to the right. So it is up to you. So let's say I have this one, x squared sine of 2y plus 5z minus y minus y cos of x z. Then it is equal to 0. So now you can see it is a bit longer, right? So imagine you have to find, let's say you don't want to use the formula, so I'm sure that your steps, you need a lot of steps, and then your expression becomes more messy. Okay, so now the formula is you want to obtain the del z over del y, so you have to put negative fy over fz. Okay, so now we start to okay, so negative, okay, fy. But if you think that you don't want to put directly into the function, into the answer form here, then you can do separately, because sometimes you need to apply the quotient rule, and maybe you need to do a lot of chain rule, and you need to have the product rule, so it's become more complicated, right? So you can do separately first, and after that you put the answer back here. So, okay, let's say I do separately. Okay, so firstly fy, I want to obtain fy. So you want to differentiate y, which means that x and z constant. Okay, what is your y? So your y is inside the sign, and x squared here constant. So you can just have x squared, and then you have y is inside the sign. You have to apply the chain rule, the standard chain rule. So differentiate the outer. You have cos of everything in the bracket. Okay, and multiplied by the derivatives of the inner function with respect to y. Okay, so you have 2y plus 5z constant, so this one 0, and this become 2. Okay, 2. Okay, and then minus 1 is constant, so 0, and this one you have minus y cos xz, so y is just single out there, and then you differentiate, meaning that cos of xz, it is a constant. So when you differentiate negative y, it's become minus 1. Okay, so the answer becomes minus cos of x. Okay. Okay, so now we look at the formula. You need to differentiate f with respect to z. Okay, so we look at the expression again. So remember now you want to differentiate with respect to z. So xy constant. So x constant. So now your z is again inside the sign. So you still have x squared there. And then differentiate the outer function. You have cos of everything in the bracket. And multiply by the derivatives of the inner function here with respect to z. So this non-z, which means that the y constant. Then differentiate of z. Then you just get 5. Okay. And then you want to differentiate this with respect to z, so this is constant, so 0. And here, you have to look at here, the z is inside the cos, but y is constant. So meaning that you just have minus y and differentiate the cos. Here you need another chain rule, because z is inside the cos. So you differentiate cos, you have minus sign of everything in the bracket. Okay, and multiply by the derivatives of the inner. So your inner function is just xz. X is constant, so you differentiate z, you will get just x. So now we plug in. So fy, you have 2x squared cos of 2y plus 5z minus cos of xz divided by 5x squared cos of 2y plus 5z, negative, positive, so plus x, 5x, yx, sorry, plus yx sine of x. So that is the answer. You can just leave your answer in this form, or you can just expand. You can put cos xz minus 2x squared cos of 2y plus 5z. So both are correct. Sorry guys, I forgot to put this on. So hopefully that you can hear me clearly, but I feel that there's so much noise, but I think still can be heard, right? So sorry about that.